Um, there is a quiz posted on Blackboard for today, so we're going to keep the lecture a little bit short to give you guys some time to work on that quiz, just because it is a little bit longer. So today we'll look at another problem very similar in style to the ones we've been looking at. It'll look like this. So we have a circle with a diameter of 200 millimeters. Tangents coming off that circle at a 5-to-1 slope, 5-to-1 aspect ratio, going down to a flat base that is 80 millimeters. Two things I want to find here. I want to find x, the overall height of this, and again, I want to find the area. This is really similar to the cam area problem we've done each of the last couple of days, only instead of a circular end here, it's a flat end. Having that flat end changes our calculations quite a bit because we don't have that second end or second dimension to work off of. But our initial step is still the same. We have a circle with a tangent or tangents to it. We're going to draw in those tangents, or the radius to those tangents, to get our right angles. So there's our first set of right angles right there. Now, one of the keys to working with right angles is if we know that if it forms a right angle, the amount that one side is away from the vertical is the same as the amount the other side is away from the horizontal. So let me show you what I mean. If I draw in a vertical here from that angle, from that vertex, and a horizontal here, this angle and this angle should be the same. This angle down here can be found. If I extend that down, I don't have to extend it down all the way. That is just the 5-to-1 aspect ratio. Basically, I'm just completing that triangle there. So in that aspect ratio, whatever this angle is has to be this angle right here. Well, that angle is going to be found using a tangent. The 5 is the adjacent side, and the 1 is the opposite side. I write up my definition of tangent. Tangent of theta is opposite over adjacent. The tangent of that angle is 1/5. Since we're looking for a missing angle, we find that angle by using the inverse trig function. So in this case, an inverse tangent. Inverse tangent of 1/5 is 11.31 degrees. So that angle being 11.31 degrees now tells us that we can come up here. This is 11.31 degrees. This angle over here also has to be 11.31 degrees. Because, of course, the radii of the circle are the same length, so that's an isosceles triangle. Because this is symmetrical, we know this point and this point were the same height, so that horizontal line we drew in there does connect them. Now, what that tells us from there. I can draw straight up from the bottom like this. We said one of our other tactics or possibilities and methods we can use is to create rectangles and cut out rectangles. So I am creating a rectangle right here, and I am cutting it out. What I know about that rectangle is that it is 80 millimeters there. So this is 80 millimeters up here. To know these two sides, I know these two sides are the same, even though I drew it a little lopsided. To know those two sides, I would have to know this horizontal length across here that I drew in. Well, we can find that. I'm going to draw that triangle off to the side here. We know this is 11.31 degrees on each side. But I do also know that these sides are each 100 millimeters. They are radii of that circle. The diameter is 200, the radius is 100. And since it's an isosceles triangle, I know that if I draw a line from that vertex between the two equal sides to that opposite side, creating a right angle, that I cut this opposite side in half. This is going to be two equal pieces. So now I can focus just on this side, the right triangle. If I find that length, I just double it to find the length of the whole base of that triangle. Actually, before we're done here, I'm going to need both dimensions, so I'm going to go ahead and find both of those. I'm going to call this dimension here A, this one B. Find dimension B. B would be the adjacent side. That would be a cosine. Cosine of 11.31 degrees equals that adjacent side of B over the hypotenuse of 100. So let's make that into a proportion by putting it over 1, and we'll cross multiply and divide. The cosine of 11.31 times 100 divided by 1 gives us 98.06 millimeters. So B here is 98.06 millimeters, making the whole distance across there 196.12 millimeters. I also want to find A while we're at it. A would be the opposite side according to my 11.31 degree angle. Opposite and hypotenuse make the sine. So sine of 11.31 degrees equals that opposite side of A over my hypotenuse of 100. Once again, I'll make that into a proportion by putting it over 1, and I will cross multiply and divide. Sine of 11.31 degrees times 100 divided by 1 gives me 19.61 millimeters. A 19.61 will become important here coming up. So now let's go back to here and let's look at this triangle over here in purple. What I know about that triangle, this angle down here is still 11.31 degrees. I also can find this side here by taking my 196, subtracting the 80 from our rectangle, which gives us 116.12. And then we have to divide it by 2 because half goes to each side. Divided by 2 gives us 58.06 millimeters. This is 58.06 millimeters. Now I need to find this side over here. I'm going to label that side D. This one right here. According to the angle, the 11.31 degrees, the 58.06 is the opposite side. Side D is the adjacent side, which makes up a tangent. So a tangent of 11.31 degrees is the opposite side of 58.06. Over the adjacent side of D, put that over 1 so I can cross, multiply, and divide. 1 times 58.06 is 58.06 divided by the tangent of 11.31. Gives me 290.30 millimeters. So at this point, I have all the information I need to find the dimension x. I'm going to cut x into 3 pieces. This piece here is what I just found, 290.30 millimeters. The next little piece from here to here, up to the center of the circle, is what I had over here, 19.61 millimeters. And the rest of this up to the top is just this distance right here, a radius of the circle, which is 100 millimeters. I add those 3 dimensions up to get a total. Oh, what is that? 309, 409.61 millimeters. My total. That's these 3. Yep. That's a mouthful. Finding the area, once we've done all of this, the area is not that hard. It's just a matter of exhausting all of the different shapes. So I will start out with shape 1 here, which is 80 by 290.30. Giving me 23,224. And that, of course, is millimeters squared. My second shape is going to be these 2 triangles here. They're mirror images of each other, but they are exact same area. That's actually this triangle here. It'll be 58.06 by the 290.30. Since it's a triangle, it's divided by 2. Since there are 2 of them, it is times 2. Giving us 16,854.82. Millimeters squared. Next, we have this triangle here, which is just this one over here. Has a base of 196.12 times the 19.61. And of course, because it's a triangle, usually that's divided by 2. Giving us 1922.96. Millimeters squared. And lastly, we have this sector of a circle up here. To find that, we need to know this angle here. To find that angle, I'm going to go back to this triangle. If this is 11.31, this angle here is 90 minus 11.31, or 78.69 degrees. Which means this whole angle here is 2 times that. 2 times 78.69 is 157.38 degrees for that angle. Which means this angle here is 360 minus the 157.38. So that's 202.62 degrees. So the area of that sector is the area of the whole circle, so pi times 100 squared, times that angle of 202.62 degrees over 360. Giving us 17,672.97. Millimeters squared. Now we add those all up to get our total. At 59,674.75 millimeters squared. Now I am going to convert this to square centimeters, just because that's a really large unit. Convert it to centimeters squared. Remember, from millimeters to centimeters is one spot on the chart, but since it's squared, each spot on the chart is multiplying or dividing by 100. So it's moving the decimal point 2 decimal places. That makes this 596.75, if we round it, centimeters squared. Now this answer is acceptable as well. I just wanted to review making that conversion with our units of area. So the tricky part of these, again, as always, the first step isn't so bad, drawing in that radius to create the right angle. But in this one, we have to use that trick. We have to use that horizontal and vertical lines, knowing that they form a right angle. But then in this one, the trick was knowing that if we have another right angle on that same vertex, they form that same angle. Let me sketch out what I mean here. So there was our radius, and there was a tangent. We knew those formed right angle with each other. But if we drew in horizontal and vertical lines from that same vertex, we knew that they had to form the same angle to each of those sides of that right angle. And that's really one of the biggest tasks to simplify a lot of these problems, is being able to figure out what angles have to be equal, what angles have to be the same. Well, like I said, I wanted to make sure I give you time to do this quiz. There's a quiz posted in Blackboard, and there is another worksheet posted in Blackboard of a problem very similar to the one we just did with just different numbers in it. so that you guys can give that one a try on your own, see if you can repeat the calculation. With that, I believe, I want to double check here, but I have a couple of you that have not turned in the test from last Thursday yet. And the quiz from earlier in the week last week. I see there's one in there that it's been turned in and I haven't graded yet, so I'll get to that hopefully this afternoon. If not, I will get it by Monday's class. I'll definitely have that graded in the book. But there are actually a couple of you that are missing the last two quizzes in the last test, so make sure you're going online and finding those and getting those completed. I know we've got like 5.5 weeks left, but we are getting down to crunch time here. Time gets away from us very quickly here at the end of the semester. So with that, I will shut off the recording. If you guys would like to continue to work on these, I'll stay on the network with you if you have any questions.